Thanks for having us. So yeah, let's continue. Let's start. So have you ever wondered if project monitoring can be improved with machine learning? So this is exactly what we asked ourselves at Silke. And we came up with the idea to identify problematic projects which will have unexpected high costs at the end of the project. So welcome to our talk about detecting project overruns with time series models. My name is Sascha Wieser, and that's my colleague.
Silvan.
So first we'll have an introduction about the problem statement which we have to face at Silke, and then we will present our modeling approach, the data set we used, and a forecasting method compared with a baseline model. And finally we will show how we integrated, or how we try to integrate the solution into our business application, into our production systems, and then we will highlight some future improvements.
Thank you. Does this work? Yes. Okay, so we're from Silke. We're a global innovation service provider. This sounds very fancy. What it basically means, for the sake of this talk, is that we do a lot of projects. Actually, really a lot of projects. And if we look at such a project from a financial perspective, there are like two types of costs. You have the expected costs and you have the actual costs. The expected costs are the budget, so an estimate how this project will cost. And on the other hand, we have the actual costs. So we have our developers, they work on the project and they build their time on it, and then we see how much it actually costs. I mean, these costs have to be somehow in balance, and next to our project managers, we also have a dedicated team who really control these. And I mean, of course, it can always occur that you have an overrun, so the actual costs exceed the expected costs. And I mean, this can happen, but at least you want to detect this as early as possible. Should be an easy thing. I mean, that's what we all should do. The challenge here is really that this should scale. So we have really a lot of projects. I mean, in 2021, we had 1,500 employees, and this meant that we had over 500 concurrently running projects. But to make things worse, these like costs we have seen, they are not even on the project, but they're even on project phases, which is like a smaller unit of projects. And from these, we have over thousands. So we have this team which has to monitor over thousands of project phases and see if the costs are still within the budget. And this is a challenge, of course. And since we love to throw machine learning at challenges, and I want to see if this works, we also asked ourselves in this project, is this possible to support this task with automation, with machine learning? And so the famous ZPOP was born, the Silke project overrun prediction, which sticked as a catchy phrase for the whole project and made it easy to also promote this internally.
So yes, thanks. So let's continue with the problem modeling. So in the Silke project, the project members book their time onto a specific project phase, so this sub phase, and so these are actually then costs, which are time series data. So we see the costs represented as the black solid line, and we also have a defined budget at each time point. So the budget is colored now in blue. And now we would like to have a forecast to the end of the project phase, which is inserted by the project manager at the start of the project. And then we can compare the cost forecast to the actual defined budget at the forecasting time point, and then we decide if the project is classified as an overrun or not. Here it would be classified as an overrun. So the time goes on, the budget was then increased, and if you forecast again, it is not classified as an overrun. Okay, so now to explore our approach, we first need data. And we extracted 1 year of data from our ERP system between 2018 and 2019. And we then selected a subset of projects based on different criteria, such as a minimum duration and minimum budget. And then we get the final data set, which consisted of more than 80 projects, which are based on more than 200 project phases and more than 50,000 time bookings. To evaluate the machine learning model, we always first implement the baseline, right? And for that, we have chosen an approach which our project managers at Silke had already used themselves. So at Silke, the project manager staffs the project members over a certain time. This can be for a specific task or for the whole project lifecycle. And this is called staffing information. And in this baseline model, we use that staffing information to get to our forecasts. And this very simple baseline model achieved a relative mean absolute error of 26%, which we evaluated on the last 25% of the project phase duration.
So this baseline has now like one great weakness. It only looks like at the total past costs, and then it looks at the plan, and then it does this forecast. And I mean, that's not machine learning. We want to, of course, also like learn from this past data. And one very simple approach to do this is with a statistical time series model from the SARIMA family. The SARIMA model consists of different parts, and you find it like without the S, without the I, and so on, and sometimes even more. But basically, these 4 components here are the important ones. We have the seasonal part, which we have because we have a really weekly behavior in our costs. If you look at this from a daily perspective, I mean, we have people not that much working, at least over the weekend. We have people who work part-time and so on, so we have really a weekly behavior here. We have the autoregressive part because our costs should somehow have a continuity, otherwise it would be hard to predict at all. We have the integrated part because our costs sum up over time, and so we only want to actually look at the difference. And we have the moving average because this is a really noisy system and we need to somehow model this error. These SARIMA models are really popular choice. I guess everyone here knows them, so I won't go into much details. It's also, they have an order in it, so you need to like find hyperparameters for these different parts. And the good thing was that we found that we can actually fix these hyperparameters over all the different cost series. So this saved a lot of compute. We didn't need to, for all these thousands of cost series, find them again, but could fix them and get comparable results if you would need to tune them for every series. If you use this SARIMA model, we could already decrease our error by 5 percentage points. We were left with 21%. But now, actually, we're in the other extreme. I mean, now we said that we only looked at the plan. Now we didn't look at the plan at all. We only look like what did it cost in the past, and now then we predict in the future. And I mean, in the end, what we would like is a hybrid approach. We would like to learn from this plan. I mean, this project manager entered this data. They know why. But we also want to learn from the past and see, like, was this always correct? And the solution there was to use a SARIMAX model, which is an extension of the SARIMA model, and this X is for the exogenous factors. What you can do there is like feed in external data to this model. And this is great because we can feed in the baseline into this model, and then in the past the model can learn like, okay, my project manager said it will cost that much, but actually it costed that much. So it can learn the mistake of the staffing and then use this mistake prediction in the future and correct the staffing. And this turned out to then again decrease our error by another 5 percentage points. And this was then also the model we selected for all future evaluations. So far we have always talked about this forecast. We have seen these predictions and we have evaluated this as a regression model. But I mean, we started the presentation as an overrun prediction, which is more a classification task. And if we have a classification task, we absolutely need the confusion matrix. So otherwise we're not happy as a data scientist. And so to get this, we have the ground truth. We have if a project overran or didn't overrun. And that's the ground truth. On the other hand, we have these confidence intervals, which we also have seen already in the Swisscom talk, where like we have an estimate depending on the forecast we have, on like how likely is it that this project will overrun from our forecast. And we again also applied here this color threshold. For example, red, we're really sure that this project will overrun, or yellow, we're like just have an estimate, and it might be that it overrun, but it could also go well. And then based on this, we can calculate recall and precision. And we see here, for example, in the yellow category, where we have like this first impression that it might go wrong, we have a very high recall, actually. We like find nearly all the overruns, 81%. But on the other hand, we have this really low precision of 54%, which in the end results in a lot of false alarms. So our project manager will just constantly get annoyed with emails that the project will overrun, which might not be true. And so to then overcome this, we can adjust this threshold and can like change the category and like trade recall for precision, and we see this. What we also see here is a very interesting pattern that actually we don't get that much precision while quickly losing in recall. And we were wondering, like, why is this the case? Why do we can tune the working point, but it doesn't pay off as much as we would have hoped. And the reason for this will be presented later by Sascha, because we have their data quality issues. So actually, we really can't get better than this because of some inherent properties of the data we will see later.
Cool, thanks, Silvan. Now it's time for some examples, right? So here we see this weekly pattern, as Silvan already mentioned. So here's the costs in blue, and now we would like to have a forecast at the prediction start point, and we see on this very simple example our model works pretty well. What if costs have unexpected dynamics, right? So here we have an example. Before the prediction start, the costs steeply increased, and afterward it's flattened out a bit. So here the model has to rely on the staffing information, and of course they have to be entered cleanly in our database. Otherwise, if we don't have staffing information as illustrated in the right figure, we can see that the model has no chance to predict that suddenly a lot of people start working at the project phase, which was almost dead before due to the costs. Okay, now let's create a business value from our models. And to do that, we have to integrate this solution into our into our production system. And here we see the ERP system, which we have already mentioned, which we extract data and feed them into the ZPub solution. And first, our solution does predictions for all currently running project phases at Sülke, and we then can aggregate those to the project level, and we see the final classification represented with those different colors, which Silvan already explained to you. And now the finance and controlling team at Sülke has a tool to quickly analyze the financial situation of all currently running projects at Sülke. And secondly, the solution also sends alerts to the project manager in case of an overrun, and then the project managers can analyze the situation, possibly take countermeasures at an early stage and avoid the overrun, or mute the alert if it's then false alarm, right? Okay. During the development of this solution, we also made some findings. And the first one is about data quality. So data quality sometimes made it hard for us to get reasonable forecasts. And one such example is the project phase end, which is inserted by the project manager at the start of the project. So we computed the actual phase end based on the time bookings. And then in this example here, the project phase end is much earlier, so the error is smaller. And we did this for the whole data set, and then the error gets halved to 8%. So hopefully with this solution in production, we also can improve the data quality at Sülke. And another one is it's more of a confirmation than actual finding. So visualizations are key for us because we created a simple demonstrator with our meeting with the stakeholders. And in the demonstrator, they could see like this predicted trajectory, and they could understand what's going on. And for them, this was very inspiring. So that's why visualizations are always key for us.
Thank you. So we have this MVP shown here. What do we want to do if this is finished? At the moment, we're building this, and then there are like 2 future steps we'd like to do. Like one is a user study. So far, we have done all this analysis, as was already mentioned a lot of time in these Jupyter notebooks. It was like a static analysis of the past. Now we really want to see like, what does this really bring to us at the end as a company? It's really a user study. We want to split the users, see like how does it differ if we use the product versus if we don't, have a controlled setup, and there like see if we're really in the end able to detect overruns early and maybe even prevent some of them. And the other thing, so far we have mostly talked about this combination of the baseline with the rule-based staffing approach and the time series statistical model, and which were combined. There are, of course, a lot of more models out there which are potentially more powerful. We would also like to use these. We didn't use in the first place because we like this interpretability of these models because, in the end, we go to these project managers and claim that their project will overrun. And then it's good if we also have a reason for this and not just like a black box. So I still want to use an interpretable model, but of course there are also like more expressive and still interpretable models out there, like the temporal fusion transformer. And we also want to use these and see if we can also use more data with this. Because so far we have just the aggregated costs over the whole phase. But it will also be interesting to look at the bookings of individual project members and see like if there are patterns there. Of course, we want to use like holidays or also expense reports. There are tons of data in our system, which could also help in prevent, like at least detecting these overruns. And that's what we also want to do. Yes, thank you very much for your attention. I hope it was interesting, and we will be happy to answer any questions.
Thank you. And indeed, we have time for questions. So does anyone have any questions? And by the way, there's some beautiful empty seats back there, front here. Any questions?
With the data, were you able to see if there was what was causing project delays? Like, was it a particular project manager that was budgeting incorrectly always, or was there some pattern that stuck out?
Yeah, we did grouped analysis where we like looked in what departments are overruns more likely and so on, and what project types. I mean, you have the findings which you could expect. I mean, there are more innovative projects which are also paid by time and material, and they're more likely to overrun because it's not that clear at the beginning what the project scope is around. And there are like very clear projects where you have also fixed price in the beginning, and there it's much easier also to estimate the costs, and you might also be a bit more progressive in these estimates, and then the overruns are less likely. So we saw these patterns. We didn't see a lot of really like time series pattern if you only look at the trajectory. So there, if you like neglect all the other information, there it was really hard. Yeah. We also, for example, like thought, well, I mean, we tried also like neural networks for this, and they actually performed very similar on the same data, which showed that there is not a lot of pattern there, or at least it could not be recognized without external data there. Thank you.
Other questions? One more in the back.
Thank you for the presentation, first of all. So the first question is this project going to overrun according to your predictions? But the more important question is like, how is the cost recorded? Because it seems to me like it's quite continuous in the time scale that you projected. So like, is it daily recorded, hourly recorded, or like, what would you say about this?
I mean, we have our time booking, and it depends a bit on the project. Ideally, it's recorded daily. Sometimes if you're like, last minute hacking and then just need to leave, then you won't be able to enter your times. I mean, we have an app, you could do it on the train, but in the end, we have like a fixed point at the end of the month, then their bills need to go out, and there it needs to be fixed. So we have this challenge a bit, yes, that's really, I mean, we have this fixed point at the end of a month, we know everything is fixed, and otherwise, I mean, in this static series, we hadn't this problem, because, I mean, there all the data was there, but for the lively running model, we would need to like, look at this trajectory for each user and see like which was the last time the person entered the time, and then predict from there on, and can't have a fixed date, because then we would have always this flat ending of the curve, yes.
I see. And also the one final question, are you planning to consider the interactions between the projects if it ever exists actually? So maybe you are working like on multiple projects that's coming from the same customer, and if you are like going over budget and it affects the other project as well, so.
There are no plans for this, but this would of course be really interesting, yes.
Good. If there are no other questions, thank you very much again.